Hey everyone, Dr. J here. This is going to be our quick video on the osmolarity of Gatorade experiment. So I have a couple things on the board. It's also written in your lab, actual lab for this one, but I just want to make sure I cover a couple things. So follow me to the board, okay? So today's lab is all about osmolarity. Osmolarity is really about particle density. Okay, particle density per liter of fluid. So the key word is density. Today, we're looking at Gatorade, common sports drink, right? The particle we're talking about in Gatorade would be sugar. Because what is Gatorade but sugar and water, right? So the particle we're specifically talking about is sugar. So when we say the osmolarity here is the sugar density, it turns out that there's an appropriate amount of sugar and sugar density for optimal absorption, okay? Which we'll discuss in a moment. I just want to make a point. We're really talking about density. Today's particle for Gatorade is sugar. Osmolarity is not necessarily about the concentration or how much sugar. So this is a different question. Osmolarity is different than how much sugar is in it. We're talking about the density of that specific sugar. Now that being said, even though it's not necessarily the same as amount or concentration, osmolarity is more about density, they are related. So usually when there is more sugar, the osmolarity or density also goes up. So they're usually related, but I really want to get you to put those two words together. I know it sounds like a fancy chemistry term, osmolarity. It's really about density. Now, I just mentioned that for athletes and sports drink, there's a range that is best for gut absorption. You need to know this range. Between 200 and 400 is the optimal range for osmolarity or density of the sugar in a sports drink. The actual unit is milliosmoles per liter. You don't need to know that, but the optimal range is 200 to 400. Today, we're going to be testing, is Gatorade actually the optimal osmolarity for gut absorption? Or is it not, and they just want to sell you stuff to make you buy money? Or is it really legitimate? Really quickly, this is a pretty high range. So it's fairly high compared to other everyday drinks. But we don't want it to be too high. So if an osmolarity of a sports drink is too high, if it's too high, it'll actually reduce gastric emptying, which means that the fluid will stay longer in your gut. And if fluid stays longer, it gets retained, it feels like there's extra fluid, it's jostling, and also you're not getting the benefit. If we can't actually absorb it through our gut wall into the bloodstream, we're not really getting the benefit. Okay, so this experiment, we have two. We have the full strength Gatorade, and we have the half strength. What we're using today is something called a refractometer. It's one way of measuring density. So what I'm going to do is, we're going to start with our full strength. I'm going to put one dot on our refractometer. Technically, this measures how much light gets through. So if a particle has a higher density, it's almost like thicker, I guess, almost, or cloudier. And if it's higher in density or osmolarity, not as much light gets through. That's how they test it. So I'm going to close this and slowly look into the light, and I'm going to read a number. I have the number. I'm recording it here because I've got to change the screen to show you what it looks like. So we're going to do a full strength. Do you ever dilute your Gatorade? I know when if I ever need Gatorade, I prefer to dilute it because it's just a personal preference. It's a little too sweet for me. So it's pretty common practice to dilute it. So now we're going to take the diluted one and this is not going to be as dense, so the osmolarity is going to be less. So let me record what I have here. Now I'm going to turn the screen over to our results, and then you can plug in the numbers and you can calculate it yourself. So bear with me here. Let me go to our results over here. I know the top is kind of cut off a little bit, but our full strength reading in milliosmoles per liter, 1.029. Check my results over there. The reading for the half strength, 1.016. When I looked on the refractometer, this is what I saw. So for the full strength, when you look at the refractometer, the fluid comes up, and you're supposed to read right where the fluid ends and the clear begins. So 1.029. This was the half. It was 1.016. So it only came up to about right there. 1.016. Now for your calculations, you only need the last two numbers, 2916. To calculate your osmolarity, multiply 29 times 14. And then for the half strength or diluted, 16 times 14. That'll give you the number. Again, we want to see, does it fit into the optimal range, which is 200 to 400 milliosmoles per liter. All right, well done, folks.